अस्सलाम वालेकुम जी। आज आपकी आई विल बी कवरिंग योर लैब नंबर 3 which is on common source JFET transistors frequency response. ठीक है, previously we covered the variation of the gate supplies when how and why a negative gate supply is required, and what happens if it's zero, what happens if you decrease it to a negative, how the response of a JFET changes accordingly. ठीक है, so now we are moving toward the amplifier version of your JFET. ठीक है, how it works as an amplifier. ठीक है, so previously we had been applying DC voltage to your amplifier. ठीक है, now we are moving toward this step in which we will be superimposing your AC signal on your DC bias voltage. ठीक है, so why and why we basically need a JFET transistor. So concept is that जो BJTs होते हैं, they have a noisy effect when we move toward the smaller millivolts. ठीक है, तो वहाँ पे JFET amplifiers is a better option. आप इनको use कर सकते हैं for small signal amplification. ठीक है, because they have very extremely high input resistance which make them a low to give a low noisy output, right? So and yes, we will be using a common source JFET amplifier. So before going into the amplification procedure, I will discuss why why we need to bias a transistor. So what itself biasing is? Biasing is the setting of initial operating condition of current and voltages for any active device. ठीक है, so what we actually do is that आपका जो ट्रांजिस्टर होता है, it works it at a specific voltage in saturation. So for amplification, we want our transistor to be in saturation mode. So to take it or to trigger its saturation mode, we initially supply it a DC voltage. ठीक है, वो DC voltage आपके ट्रांजिस्टर को saturation mode पे set कर देती है. Then we superimpose an AC signal on that DC voltage and we basically amplify it and we make our transistor as an so we convert it into an amplifier by initially biasing it. So itself biasing is applying a DC voltage. ठीक है, ये फीचर जो है ट्रांजिस्टर्स के अलावा वैक्यूम ट्यूब्स में भी है. वी somehow minorly डायोड्स में भी आप इसको कंसिडर कर सकते हैं, बट मेजॉरिटी biasing concept of biasing is for transistor. You will hear it for transistors. ठीक है, now we will be discussing n channel JFET in depletion mode. ठीक है, I have discussed depletion mode in previous class and why n channel JFET or JFETs are normally in on state. I have discussed that too. ठीक है, कि why it is considered in normally on state. And let's move toward your biasing procedures. ठीक है, now there are three set of procedure: gate biasing, self biasing and voltage divider biasing. ठीक है, now we will be in this specific lab we will be applying the procedure of self biasing. Now I told you what biasing is, and you know from your previous labs when you are biasing a JFET, its voltage at gate or its VGS voltage should be negative. ठीक है, it means your gate should be negative compared to your source voltage, right? So this is the initial biasing condition for your JFET for it to work in saturation mode. ठीक है, now these if you see its graph, तो इस linear voltages के अलावा this entire region is your saturation region. So it means that after a specific amount of VDS voltage, your transistor turned into saturation mode, but the condition is कि आपकी gate voltage should be negative. ठीक है, और zero. This in first for zero, then आपकी negative voltages आती हैं. So the first initial condition is कि आपकी VGS negative होगी, then आपकी VDS should be in a specific range. That's the second condition, right? So biasing technique we will be discussing and we will be doing or implementing in our lab is self biasing. So let's move towards self biasing. This is a circuit of your lab. and we will be performing it in multisim. We will be applying a 12 volt DC supply for biasing. Now when we are considering the circuit of biasing, we do not consider these capacitors, ठीक है, कंसिडरिंग द फैक्ट कि आपके ये रेजिस्टर्स हैं, ठीक है, आपने एक हाई इनपुट रेजिस्टर यूज़ किया है. दिस रेजिस्टर बेसिकली यूज फॉर द कॉन्सेप्ट इटसेल्फ. जो आपकी ट्रांजिस्टर की गेट इनपुट इम्पीडेंस होती है वो हाई होती है, देन यू आर यूजिंग इट विद अ हाई gate resistance 10 mega ohm, ठीक है. So very minor current will flow through this path, ठीक है. So its input impedance is very high, so entire current is flowing through this path. So now let's move toward VG. When we, by our concepts, we assume कि if IG is equal to 0, it means that VG is equal to IG into RG is equal to 0, ठीक है. Let's just do minor calculation so your concept is clear and you can easily grab the concept of amplification, ठीक है, JFET amplification procedure, how a signal is amplified in a transistor. So now when your VG is equal to 0 and your VS is equal to ID into RS, this is the current flowing through your RS ID current, so it means that VS is equal to ID into RS. Now we know you can find it out by putting just an ammeter here, ठीक है. In your multisim, just put an ammeter here. You can simply find out the ID current for your biasing stage, ठीक है. So if 1.8 is your ID current, 1.8 milliampere, so this term is for milli, this is your RS, so it is the value of your VS. It means that VG minus VS is equal to negative 0 minus 0.8. So initially when you applied a voltage of 12 volts here, ठीक है, so आपने VGS को नेगेटिव कर दिया है. इट मीन्स कि आपने जो बायसिंग इनिशियल कंडीशन है उसको ट्रिगर कर दिए, सही. Now let's move toward VDS. What is your VDS in this specific circuit? सही है. So VDS is equal to VD minus VS, whereas VD is equal to VDD minus RD into I of t, सही है, और minus V of S. Now you can V of S को आप रिप्लेस कर सकते हैं ID into R of S, एंड इसमें से आप ID कॉमन ले लें तो ये आपकी फाइनल टर्म बनती है. एंड यू नो that in our circuit we are applying 12 volts minus ID is 1.8 milliampere and plus these are the two resistance. If you calculate it out, so VDS is equal to 5.2, ठीक है. So what it means, now let's move toward your load diagram, DC load line, DC load diagram, this entire characteristics, ठीक है. Now let's discuss it. Now I have said to you कि आपकी voltage maximum is 12 volts. It means if we consider that no current is flowing through a drain, then VDS is equal to maximum VDD. So it ranges from 0 to 12 in your present scenario, ठीक है. And if your VDS is equal to 0, then maximum IDD is equal to VDD divided by R, which is equal to 3.18. So this is your maximum current. Now you know that load line is drawn by joining these 2 points. Now also you are familiar with the concept कि ये सारा area आपका linear behavior of your transistor है. It means कि other than the value of VDS approximately 1.5, ठीक है. So a value greater than 1.5 and approximately up to 12, ठीक है, somewhere in this region, ठीक है. इस region के अंदर whenever you are applying any millivolt signal, AC signal, you can amplify it. But now it totally depends on this factor कि if you are choosing a quiescent point, means your VDS is lying somewhere in around 5.6, 6, ठीक है. In that case your transistor will behave as a class A transistor, ठीक है. If you are moving toward this side in such a way कि just आपका एक side जो है either upper half of the wave आ रहा है या lower half of the wave आ रहा है और rest जो है वो clip हो गया है, ठीक है, यहाँ पे जाएं या यहाँ पे जाएं. In that case you are using your transistor in class C operation, ठीक है. और अगर आप ऐसे जाएं कि आपका half of it क्लिप हुआ है, हाफ नहीं हुआ, देन आपके A, B and B आते हैं, ठीक है. यू आर फेमिलियर विद दोज कॉन्सेप्ट. सो वो सारे एम्प्लीफिकेशन प्रोसीजर टोटली डिपेंड अपॉन योर क्यूसेंट पॉइंट, विच पॉइंट you are using, what is your VDS voltage. Presently in this scenario, our quiescent point according to this set of voltage is approximately mid. It means presently we will be using it as a class A amplifier. सही है. Now when you have set your biasing voltage, then comes your AC model. AC model में we basically use these two capacitors which are coupling capacitors. ये coupling capacitor, any additional DC from your input voltage or your from output side या from your cascaded जो आपके multiple transistors होते हैं, उन सब का DC element block करती है, because you have already set your transistor in biasing mode or in saturation mode, so you do not want any additional DC. ठीक है. So you are using these capacitors. Plus this capacitor, bypass capacitor, is actually bypassing low, it is used for low resistance path for noise present in AC signal. So this is used for your blocking of AC noises. ठीक है. So when you transform it into AC model, आपका ये RG signal है, ठीक है. Your capacitors are acting as a short circuit for your AC signal, ठीक है. Here comes your model of transistor, ठीक है, AC model, and additionally there is a RD resistor. So this is your AC model of your transistor. Now you are familiar with this entire curve, ठीक है. Maximum current is IDSS, which is at VGS is equal to 0, right? And when you basically decrease your VGS towards the negative side, आपका current decrease होता है. So this is your load line graph. And I said to you कि depletion mode में at VGS is equal to 0, there is a maximum flow of current and your transistor is in normally on state. ठीक है. You know that from your previous labs. And when you go on decreasing your voltage, your current starts to decrease. सही है. Voltage of VGS. Now disadvantages of JFET. One of the disadvantages कि it needs a negative voltage और additional कहीं से भी आपका minor fluctuations of voltages आती हैं, तो आपका transistor in that state आपको क्या हो जाएगा, amplification factor fail हो जाएगा. ठीक है. But these limitations can be covered by JFET, but this is a very good option of amplification, JFET, because it has a very high input resistance, so its amplification is very fine. But those issues which are in BJT are covered by JFET, but the issues of JFETs are majorly covered by MOSFETs, right? So this is so for your details of lab. We will be discussing your data sheet when we move toward the lab part. We have covered so far your theory part, and then we will be discussing your table and all of the rest of the elements, right? So we will be taking details of frequency, input voltage, output voltage, and we will be finding the gain of your amplifier, right? And the transistor we will be using as an amplifier would be BFR30. So let's move toward your second part.